Hey everyone, welcome back from break. This is take number 3 on this video, so I'm a little frustrated, but that's okay. The sound didn't work when I went through into this the first time, so let's hope it's working now. Anyways, so I will be gone both today and tomorrow, so you'll have 2 days with the sub. I believe it's the same sub both days. After today, you will have a short homework assignment. You'll have, I think it's 5 or 6 questions tonight and 5 or 6 questions tomorrow. It's one worksheet, so you'll have the front side of the worksheet tonight, the back side tomorrow, and it will all be due Monday. I will type all that out on Google Classroom so there's no confusion. So the nice thing is, kind of like last time I was gone for 2 days, the note section is something you've learned before. It's the quadratic formula. So with the quadratic formula, the key here is, first of all, if you look at the example, it's ax squared plus bx plus c equals 0. It has to be set equal to 0 in order for the quadratic formula to work. The second thing I need you to know about the quadratic formula is that it should be your last resort. In other words, if you can factor the problem, factor it first. Now, the ones that we're doing today, you can't factor. That's like I have them as examples so that you can't factor them. However, if you get something like x squared plus, plus 7x plus 10, you should not use the quadratic formula for that. You should factor it out to x plus 2 and x plus 5, factor it out, and then figure out what your solutions are for. It will save you a ton of time and effort if you can factor instead of using the quadratic formula. Okay, however, for all of these, we can't do that. Okay, so before we get rolling, one thing I didn't talk about is my A, B, and C value. In this long formula that you should have seen before, you might have had teachers who have like sung a song to help you remember this. Yeah, I'm not going to do that. You can Google quadratic formula song if you really want, but I'm not singing it. But so the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Those a, b, and c values come in here. Your a is always attached to the x squared, your b is always attached to the x, and your c is always the constant on the end. Okay, one thing I keep in mind is that the sign goes with your a, b, or c value. For example, in this first one, the number that's attached to the x squared is 3, so my a value is 3. The number that's attached to just the x, the b value, is a positive 8, but we're just going to write 8 because we don't write plus 8, we just write 8. My c value on the end, however, has a negative sign, so my c value is negative 35. Now, when we plug this into the quadratic formula, again, it's circled up there in yellow. It's the opposite of b. So my b value is 8, but we want the opposite of 8, which is negative 8, plus or minus the square root of. Whenever you put something in underneath the radical, put parentheses around it. So I'm going to put 8 squared minus 4. The 4 is always going to be a 4 right there. It's just part of the equation. Okay, times my a value, which is 3, times my c value, which is negative 35, all over 2 times my a value, which is 3. Okay? The first thing I want us to do is reduce what's underneath the radical. So everything else is going to stay the same. I'm going to have negative 8 plus or minus the square root of. Now, when I do this, 8 squared, you should know, is 64. Now, you should know also that I'm not doing 64 minus 4. I got to follow PEMDAS. That's why I did my exponent first. So after my exponents is going to come m for multiplication. So on your calculator, so if you don't have a calculator right now, pause the video, go to the back, grab a calculator. Do not use your phone. It's much, much easier to screw up. Just go grab a calculator, please. Okay, now that you have a calculator, you're going to type in negative 4 times 3 times negative 35. Now, you need to include the sign as well, because if you don't include the signs, you'd get a minus 420. However, we have a negative times a negative 4 times a negative 35. Negative 4 times negative 35, and then you multiply that by 3, and you should get plus 420 all over 2 times 3 is 6. Now, underneath the radical, most of us can do this in our head, but you can type in 64 plus 420 in your calculator as well, and that whole thing reduces to negative 8 plus or minus the square root of 484 all over 6. Okay, the next thing we need to do is see if 484 is a perfect square. If it is, great. So the square root, second square root of 484, again, you should have a calculator for this. You should get 22. So this reduces to negative 8 plus or minus 22 over 6. Now again, since these are nice numbers and you have a plus minus, what I want you to do is actually go out and do negative 8 plus 22 over 6 and negative 8 minus 22 over 6. So when we do this, negative 8 plus 22, we should get 14 over 6, which reduces to divide by 2. 7 over 3 is one answer. Your other answer, we get negative 30 over 6, which is negative 5. So your two solutions to this problem are 7/3 and negative 5. Okay, on to the next example. Now, if you look here, in example 1, our equation was set equal to 0. Here, number 2 is not set equal to 0, so what we need to do is move everything to one side. I need to minus 2m, and I need to minus 3. I get 2m squared minus 2m, excuse me, that should be a plus 3 equals 0. Now it's set equal to 0, I can identify what my a, b, and c values are. A is attached to my variable squared, so my a value is 2. My b value is attached to just the m, so that's a negative 2. And my c value is attached to nothing, just my constant at the end, which is 3. So now I'm going to plug all of this into my quadratic formula. Again, my quadratic formula, opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So my b value is negative 2, but I want the opposite of negative 2, which is 2 plus or minus the square root of. Again, when you plug something in underneath the radical, I want you to put parentheses. Negative 2 squared minus 4 times my a value is 2 times my c value is 3 all over 2 times my a value is 2. Okay, now again, our next step is to reduce what's ever underneath the radical. So we get 2 plus or minus the square root of negative 2 squared. You should know that negative 2 squared gives you a positive number. But if you have to plug it into your calculator, make sure you're plugging it in as negative 2 squared, not negative 2 squared like this. You need the parentheses because here our calculator spits out 4. Here it spits out negative 4. This is what we want because we should know that a negative 2 times negative 2 is positive 4. Now again, order of operations, I need to do 4 times 2 times 3, and it's technically a negative 4. So negative 4 times 2 times 3. You can do that in your head or on your calculator. It doesn't bother me either way. But you should get a minus 24 all over 2 times 2 is 4. Reduce that. That should reduce to 2 plus or minus the square root of negative 20 over 4. Now you might be saying, well, now we have a negative underneath the square root, so now we're finished. That is not correct because, again, we can get rid of that negative underneath the square root. We have that new thing, that imaginary unit I, that we can pull out. So this is now, I'm actually going to go way over here. This is now 2 plus or minus I square roots of 20 over 4. And now you might say, okay, now I'm done. But no, because I got to look, can I reduce what's underneath the radical? Do any perfect squares go into 20? You should say yes. I know that 4 multiplies into 20. So this is now 2 plus or minus I times the square root of 4 times the square root of 5 all over 4. And then you should say, well, the square root of 4, that's 2. 2 plus or minus. Now the right way to write this is not I times 2. You write it as 2I times the square root of 5 over 4. And now, you might think you're done again, but however, this 2, and this 4 are all outside of the house, so I can reduce those 3. Since they're all outside the house, I can reduce all 3 of them, divide them all by 2, and you should get 1 plus or minus I square roots of 5 all over 2. Final answer. Okay. On to the next page. We got 2 more left. Okay, here we go. Again, we're going to list out our A, B, and C value. In this problem, it's set equal to 0, so I can jump right into it. A is 2, B is negative 12, C is 18. Now, if you're watching this, I would encourage you to pause right here, try number 3 and 4 on your own, then maybe fast forward and check your answer. You're going to get better at it by doing it, not just watching me. Regardless, when we plug this in, we need the opposite of B. So the opposite of negative 12 is 12 plus or minus the square root of negative 12 squared minus 4. Again, it's always going to be a 4 times 2 times our C value, which is 18, all over 2 times 2. Reduce what's underneath the square root. 12 plus or minus the square root of negative 12 squared is 144 minus 4 times 2 times 18 all over 2 times 2 is 4. Now I'm going to reduce the squared again. 12 plus or minus the square root of, well, negative 4 times 2 times 18, opposite of B. Excuse me, we should get 4 times 2 times 18, 4 times 2 times 18, which is 144. So 12 plus or minus the square root of 144 minus 144 all over 4. Well, that actually works out really nice. This is okay. So we get 12 plus or minus the square root of 0 over 4. Well, what's the square root of 0? Just 0. So what's 12 plus or minus 0? It's just 12. Then 12 divided by 4? 3. Look at that. We got a nice answer for once. Okay. Last one. Again, I encourage you to pause the video, try it yourself, and then come back and check. So again, we need to get everything on one side. I'm going to minus x, I'm going to plus 5. X squared minus x plus 5 equals 0. A value, 1. B value, got to include the sign, negative 1. C value, 5. Quadratic formula, x equals the opposite of b. My b value is negative 1, so the opposite of negative 1 is 1 plus or minus the square root of b squared, negative 1 squared, minus 4 times my a value, 1, times my c value, 5, all over 2a, 2 times 1. Again, reduce what's underneath the square root. 1 plus or minus the square root of negative 1 squared is 1 minus 4 times 1 times 5. Now, that you should be able to do in your head. 4 times 1 times 5 with a negative out front is 1 minus 20 all over 2 times 1, which is 2. Now, again, you should be able to do this in your head. We get 1 plus or minus the square root of 1 minus 20, negative 19 over 2. Okay, the last step then is to say, hey, I have a negative under the square root. I can pull that out and change it to an I. So now I have 1 plus or minus I square roots of 19 over 2. You look to reduce. If you can reduce boom, boom, and boom, the 3 things with the blue dots under it, like if I have a 2, a 6, and an 8, I can divide them all by 2. Here I have a 1, 1, and 2. We cannot reduce those, so I am finished. Okay, now, that is it for notes for today, which is Thursday, January 2nd, I believe. You should go ask the sub for the worksheet, and you're only doing the front side. I will type out what question numbers there are. It might be the front side and 1 question on the back. I will type out and put on Google Classroom which numbers you should do tonight, and then tomorrow night over the weekend, you will have to do the back side of that same worksheet.